Hi guys, welcome back to my YouTube channel. So in this video, we're going to discuss another set of topic in mathematics, which is all about finding the inverse of the function. So I have here examples to be shown in this video. We have 6 examples to be solved and shown in this video. And by the way, the meaning or the definition for inverse function. So inverse function is the function that reverses another function. So let us move to number 1. Let us solve example number 1. We have here the function defined by q of x is equals to x cubed. So what we are going to do in solving the inverse of the function, so we have to express first, the first step is we have to express the functional notation into y. Meaning to say you have to replace the notation for function into y, or with y, I mean. So we have here now, it will become y is equals to x cubed. So since we have here y is equals to x cubed, the next step, what we did here is just simply substitute or replace q of x or the functional notation with y. So after that, we have to interchange y and x, meaning to say you have to make y here as x and your x here as your y. So let's proceed. It will become x is equals to y cubed. Then afterwards, express the given or the resulting expression into y. So you will get y cubed is equals to x. We're not done yet. We have to make the left side as y only. So we have exponent 3 here. So we have to eliminate the exponent, which is 3. So to eliminate that one, we have to get or to extract this one by getting the cube root of y cubed. So that is cube root of y cubed, that is equals to, so cube root of y cubed is equals to y cubed is equals to the cube root of x. Why we also get the cube root of x on the to the right side? Because the rule is that whatever you are going to do in the left side must be the thing that you are going to do right side. So that is why getting the cube root of y cubed must also be, we must also get the cube root of the right side. So simplify afterwards. We have cube root of y cubed, that is only y. Okay, so y, again cube root of y cubed, that is only y, because the index and the exponent will be cancelled out. So the remaining variable will be y only, or expression. So next we have the cube root of x. We have the cube root of x. So since x is not a perfect cube variable, then we can have this one as the final answer already. So, or you can have this one as your inverse, y is equals to the cube root of 3 over x of the function here. Or you can rewrite the notation for inverse function. So we can have q to the power of -1, or that is read as inverse of the function q, or q inverse is equals to the cube root of x. So either, this is the final answer of the given function. So the inverse of the function defined by q of x equals to x cubed is, we have cube root of x. So let us proceed to number 2. So we have the function defined by f of x equals to 1 over x. By just merely looking at this function given here, we can say that this is already the inverse. There is no other inverse of this function, but it is still 1 over x. So if you want to prove that one, that still this is the inverse of this function, we have to follow again the four steps. So we have the first step is to make this one as y, the functional notation. So you will get y is equals to 1 over x. And next, the second step will be interchange y and x, meaning to say you have to make y as your x and your x as your y. And then express the function in terms of y. So you will get 1 over y is equals to x. We have to make the left side as y only. It is expressed in terms of fraction, so we have to eliminate or to make this one as a whole variable in the left side. So what we're going to do here is to cross multiply. So we have to cross multiply this one. So we can get y times x, that is xy. Then we have y times 1, that is, 1 times 1, that is 1. Now we have to express the expression in terms of y, so we will get y is equals to, or we have x, y is equals to 1. So to eliminate x in the left side, we have to divide both sides by x. Then cancel out x here, so the remaining variable will be y is equals to 1 over x. So as you can see, y is equals to 1 over x, still the inverse of 1 over x. Again, the inverse of 1 over x is still 1 over x. That is what I mean earlier before we started solving this one. So, or you can express that one as f inverse, inverse of the function f is equals to 1 over x. So this is now the final answer. Okay, just always remember or bear in mind that 1 over x has its inverse the same as 1 over x. So let us proceed to example number 3. Okay, so we have the function defined by p of x is equals to 2x squared minus 5. So what we are going to do again, the first thing or the first step we are going to do is to change the functional notation into y. So it will become p of x will become y is equals to 2x squared minus 5. So be careful with this one because our variable x here has an exponent. So we have to, the next step or the second step will be interchange y and x. So y becomes x and our x becomes y. So if x consists of exponents, so we need to say y also will be having exponent. So in terms, the third step will be express the expression in terms of y. So we just interchange both sides, so no sign will be changed. Since we just interchanged right side and left side, so no sign will be changed with that. So we have to express that one. So 2y squared is equals to x plus 5. So where did we get positive 5? We transferred negative 5 to the right side, it becomes positive 5. So our goal is to retain or to make the left side as y only. So to left the variable y in the left side, so we have to simplify this one further. So we have to divide both sides by 2 to eliminate 2 here. So the remaining expression will be y squared. So 2y squared divided by 2, that is cancelled out 2. So the remaining variable or expression will be y squared is equals to x plus 5 over 2. So where did we get over 2? That is because whatever you are going to do in the left side must be the thing that you are going to the right side. So now, since we have an exponent with y here, our goal is to make this side as y only. So we have to extract that one by getting the square root of y squared and then also get the square root of the right side, because whatever the thing that you are going to do here must also be the thing that you are going to do on the other side. So we have the square root of y squared, that is y. Then since square root of x plus 5 over 2 can no longer be simplified or factored out, or there is no square root of x plus 5 over 2, so write that one or make that one as it is. So x plus 5 over 2, since this can no longer be factored out or simplified to lowest term. So this is now the inverse, or you can rewrite that one as p inverse, or the inverse of the function p is equals to the square root of x plus 5 over 2. So this is now the final answer. Now let us move to the example number 4. Our example number 4 is defined by the function r of x is equals to 3x over 4 minus 5. So again, first step, you have to change the function notation into y, and then the second step will be interchange y and x. So it will become x is equals to 3y all over 4 minus 5. Afterwards, express the expression, the resulting expression in terms of y. So 3y over 4 minus 5 is equals to x. So we have to, our goal is to make this side as y only. So we will transfer 5. It will become positive 5. So negative 5 transferred to the other side becomes positive 5. So next, we have to cross multiply. So x plus y is automatically over 1. So by cross multiplying, we have to get 3y times 1, that is 3y times 1 is equals to 4 times x plus 5. Again, 3y times 1, that is 3y times 1. 4 times x plus 5, that is y. We get this one. Then simplify further. 3y times 1, that is 3y. Then 4 times x, that is 4x. Then 4 times 5, that is 20. Now we have to make this expression as 3. So we have to divide both sides by 3. So that on the left side, y only will be left. So 3y divided by 3, cancel out 3, that is y is equals to 4x plus 20 is, all over 3. So now, we already get the inverse of the function defined by 3x over 4 minus 5, or that is written as r inverse, or inverse of the function r is equals to 4x plus 20 all over 3. So this is now the final answer. So let us proceed to example number 5. We have the function defined by d of x is equals to square root of x minus 3. So what we are going to do again, so change the function notation into y, and then interchange the variable x and y, so it will become x square root of y minus 3. And then afterwards, express give a resulting expression in terms of y. So you will get x square root of y minus 3. Yes, is equals to x. So again, square root of x minus 3, negative 3 is not part of the radical sign here. So always remember that only the x variable was being or having a radical sign. So now we have to transfer negative 3 to the other side. It will become positive 3, x plus 3. So our goal is to make the left side as y only. So since there is a square root, we have to eliminate this one. To eliminate this radical sign, we have to square root of y. And again, we have also to square the left side, or the right side, so that we can still balance the equation. So that is why square root of y, eliminate that one by squaring both sides. So we have x plus 3 squared also. So square root of y squared, that is only y. Then x plus 3 squared on the right side. So you can have this answer. You can have this one as the inverse, or you can expand the binomial square. So the rule is that square the first term, twice the product of the first and the second term, and we have square the last term. So you can have this one as your inverse, or you can have this one, and then rewrite the correct notation of inverse. So d inverse, or the inverse of the function d, is equals to x plus 3 squared, or you can have the inverse of the function d is we have x squared plus 6x plus 9, the expanded form of the binomial square. Again, square the first term, twice the product of the first and the second term, and then square the last term. Next, we have example number 6. We have the function r of x equals to x plus 3 squared. So we have to make this one as y is equals to x plus 3 squared. That is the very first thing that you're going to do. Express the function notation in terms of y. So the next thing is that interchange y and x. So y becomes x and x becomes y. Then express the function in terms of y. That is y plus 3 squared is equals to x. And then since we have here exponent of 3, so we have to extract this one, get the square root of both sides to eliminate the exponent, which is 2 here. So we have to get the square root of y plus 3, the quantity of y plus 3 squared is equals to the square root of x, because whatever that you are going to do in the left side will be the thing that you are going to the right side. So we have the square root of y plus 3, square root of the quantity of y plus 3 squared, that is only y plus 3 is equals to the square root of x. And then our goal is to make the left side as y only, or equal to y only. So we have to transfer positive 3 to the other side. It will become negative. So y will be equals to x, square root of x minus 3. It should be that negative 3 is not included in the square root or the radical sign. So we can have now as our r inverse, or the inverse of the function r is equals to the square root of x, then minus 3. So as you can see, as you can observe, our example number 5 and number 6 are both inverses to each other. So the inverse of this function is this one. The inverse of this function is this one, and the inverse of this function is this one. Okay, so that's all for this video. I hope you learned something about the explanation I provided. Based on the capacity and capability to explain the concept of the inverse of a function. So that's all for this video. I hope you understand something, and God bless everyone. Thank you for watching.